Let's have a look at union types in Elm. And a lot of other languages like JavaScript, Java, and so on don't have union types. So this is a new concept that you have to learn when learning Elm. I'm just going to use the online editor to play around with these types a bit. Now, the first use case for union types is where you have a list of options. So, for example, let's imagine that we have a rating type. So there are three possible ratings: excellent, good, and poor. And to create a rating, you just use one of these options. So for example, let's say that our data, instead of being of type string, is of type rating, and it's going to be excellent. And if I try to run this program as is now, it's actually going to complain because text expects a string, whereas text is now of type rating. And what we can do now to fix that is to add a call to the toString function. So toString will take its argument and convert it into a string. We also need parentheses. And now it works, and our data of type rating is rendered as excellent. Compare this to JavaScript, where if you were to use string, then really anything could be a possible rating, right? So you could say bad. In Elm, that wouldn't compile, right? Because we said that we only explicitly allow any of these ratings. So this is simple, and it's similar to enumerations as you have in other languages. But union types in Elm are more powerful because these options, excellent, good, and poor, they're not just values, they're functions, they're actually called constructors. So you can parameterize these. So you could say that there's another constructor, other, that takes a string, and you can use this other with a string to create a rating. So for example, you could say data, other with the string appalling. So here we're giving the user three predefined options and another one which is custom. And this compiles and it works as expected. Let's say in the rendering you didn't want this other to appear. So you want to create a custom rendering that is not exactly the same as what the built-in toString function does. You do this with pattern matching. So for example, you could create a function called render. This would take a rating and return a string. So let's implement this. So we take a rating and then we use the case keyword to pattern match on the rating. And in case it's other s, then we return s. So other s basically runs the constructor backwards and it pulls out the s, the string that the other has been built with. And then here you can go through the other cases. So for example, in case it's excellent, then you return excellent, and so on. But just to make this short, let me add a catch-all clause and just return toString rating. So this render function only does something special in the other case. And now here, instead of toString, I'm going to use render. And now running this again just shows appalling. Another interesting feature of union types is that they can have a recursive definition. So for example, let me create a type to represent the breed of a dog in this case. So if we want our data to be a breed, we can use one of these values. Now imagine we also want to cater for crossbreeds. So we could add another case where it's a crossbreed between two breeds. So we can now have data that is, let's say, half husky and half poodle. And this compiles as you would expect. And this is recursive, so you could say that, okay, one parent is a husky and the other parent in turn is a crossbreed between a poodle and a beagle. And